a really good paper. It looked at the mechanical effect of changing that geometric design of attachments with clear aligners. Okay, so a lot of these type of studies are often done with engineering principles called finite element method analysis. So really what this study showed that actually attachment size, shape, width, length really matters on how accurate the force is applied. So what they did there with engineering principles, they know the mechanical properties of PDL, mandibular bone. So they looked at mandibular teeth. They did finite element method analysis where they built the PDL. They know the elasticity of PDL. They know, I mean, these are quite common studies now done in aligner mechanics, you know. So a majority of our aligner biomechanics is coming from this type of analysis. So it's not real mouth. It's an in vitro study. It's not in vivo, but it's kind of nice to test it on a model first before we go into a patient. So basically what they're looking at when the clear aligner goes over the tooth and you apply a mesial direction of force to that attachment, the length, the width, and the thickness of that attachment, does it influence the force and the tipping that resultant force does? If I am to apply a force like this, right? If I am to apply a force in a mesial direction onto this attachment, we want it to go mesial, right? We want it to go mesial. We don't want it to go any other direction, right? We don't want it to have like some sort of rotation in there. If you've got a beveled attachment or you've got an attachment that's sloping to one side, you're more likely to deflect that mesial force, you know, away from where you want it to be. So for example, if I want to put this mesial force, right, and the red line here is showing you a small attachment. So if I have a 1 millimeter width of attachment, we're looking at the width here. If I have 1 millimeter width of attachment, my force, instead of going mesially, it's going to go 4.67 degree off. Okay. Now, if I start increasing my attachment size and look down to the bottom, if I make the width of that attachment a bit bigger, I make it 3 millimeter, and now I'm putting the mesial force, it's going to go a lot more straighter. Only 0.99 degree of that force is deflected in a different direction. Okay, so obviously it's showing the bigger the attachment, that force direction is not deflected. But not only force, right? When you're putting a force, every force has a rotational moment, meaning every force going in one direction, because a tooth can't move bodily, has some sort of rotational effect. So they also looked at what is that rotational effect. And again, the big and often if you don't want side effects, right? If you don't want, you want teeth to move bodily, you don't want a lot of rotational effects, side effects, like that's called the moment. Okay, so you see this in the direction here, you see it in the circles here. What you're seeing here, this is showing you that if we put a mesial force, it's gonna tip mesially. Okay, that tooth's gonna go mesially a little bit. So basically this rotational component decreases. So what we're seeing here, when we have a 3 millimeter attachment here, which is the widest, you know, we can put on that tooth, on a mandibular canine, or I think this was an incisor. And what you do is when you make it really wide and you're putting a mesial force on that, okay, firstly, your force is going to be quite strong. It is a heavier force than when it's 1 millimeter. Okay, so the force becomes a lot bigger. Not only that, it's more linear direction. So your force is going in the direction you actually intend to go. Whereas here, it's not as linear. Then every force tends to have a rotational moment. It tips the tooth or rotates it in a certain way. Again, the bigger the attachment, the 3 millimeter attachment, the wide attachment, the more the moment of force, but less direction, meaning there's more bodily movement. Okay, so not only our force level increases, but we're also getting a bit more bodily movement. So when it comes to root movements, when it comes to bodily movement, we want that. We don't want our tooth to tip. We got to get as big an attachment as we can. Okay, I hope that makes it clear what I'm trying to say here. So this is really interesting. So they looked at all different types of attachments. So down here, what they're looking at as the thickness increase, then they're looking at the width, they're looking at the length. As the width increases, thickness increases, length increases, direction of the force becomes much more tighter, so it's not deflecting as much, and the moment increases. The bigger the attachment, more bodily movement, it's higher force level, and less rotational moment of the force. So it's a really, really neat study. Now, it's not in the mouth, it's in vitro, but it kind of gives you some biomechanical principles.